Yes, dear students, so today we are going to discuss LPC2148 ports and the port handling registers along with a simple example. And this session is more related to your Part B programs, hardware programs, but in this session I'll be explaining you how to simulate the hardware programs using the protest simulator. First you'll understand the ports of LPC2148 and then the different registers which are used in order to handle the ports of LPC2148, and followed by this you're going to understand one simple example blinking the LED with a small program, and I'll explain you how to you're going to write basically the C program, and I'll explain you how to convert that C program into an X file, hexadecimal file, and we are going to burn this hexadecimal file into the LPC2148 simulator, and then we're going to run the simulator and you'll observe the LED blinking. Same program when you are back to the college, if you the same X file, if you put it into the hardware which is available at the college, it gives the output on the physical LED. We'll just start with this. Okay. Now LPC2148 basically a low power controller. It has 64 pins in it, arranged in a quad inline package. So 64 pins it has. So you can see here the small picture given here. It has 64 pins. Total number of pins here is 64, and these 64 pins, they are arranged in a quad inline package. That means all pins you can find on all the sites. All the sites you can find the pins. Among the 64 pins, since you find pins along all the sides, it's called as quad inline package. If the pins are at only two sides, then it is called as dual inline package. Since here the pins are found on all the sides of the IC, it's called as quad inline package. Now among the 64 total pins, now 48 pins are GPIO pins. What is meaning of GPIO? It is general purpose input output pins. That means you can go for using this 48 pins either as input pins or as output pins. Now as two ports named, again this LPC2148 as two ports named port 0 and port 1. Now port P0 is nothing but port 0 and P1 is nothing but port 1. Now and again how many pins are there in port 0? Port 0 has 32 pins. Now like this, and the 32 pins of port 0 are named like this: P0.0, that is port 0, 0th pin. Next P0.1, port 0, first pin. Next P0.2, port 0, second pin. Like this, port 0, 30th pin, port 0, 31st pin. Now totally 32 pins are there in port 0. And the other port P1 has 16 pins. Strictly speaking, it also has 32 pins, but you can use only the upper 16 bits, and the lower 16 pins are not usable by the user. What user can use is only the upper 16 pins the user can use. Hence I say port P1 has 16 pins. So this 32 plus 16 is 48. So totally in general 48 general purpose input output pins are available. And when I say port 1, it has 16 pins. It is like this: P1.16, that is the 16th pin of port 1. Now this also has 32 pins, but only 16 pins are usable. Now what are those 16 pins? P1.6 to P1.31. So these are the 16 pins which are usable, but P1.0 to P1.15, so they cannot be used by the user. Now I have written here. Now port pins P1.15 to P1.0 are not available for user. In port 1, the port pins 1.0 to 1.15 are not available to the user, so they are used by the LPC2148 itself. Now you cannot use this port pins from the port 1 for programming purpose, what you can use is P1.16 to P1.31, whereas port 0 you can use all the pins from port P.0 P0.0 to P0.31. Now this has 32 pins and this is 16 pins, 16 usable pins, and together is 48 general purpose input output pins. Now with this you understood. So LPC2148 in general has 64 pins, now which is arranged in a quad inline package like this. Among the 64 pins, 48 pins can be used by the user as general purpose input and output pins. And again these 48 pins are grouped into two ports, port 0 and port 1. Port 0 has 32 pins, they are named like this, P0.0 to P0.31, and similarly port 1 has 16 usable pins from P1.16 to P1.31, and P1.15 to P1.0 they are not available for the user. Next, now these 48 pins which are grouped into two ports, port 0 and port 1, can perform other functions also. So it's not like you can use this 48 pins, 32 pins here and 16 pin here as the general purpose input output pins only, but you can use those pins to perform other functions also. Now generally each pin available pins 48 can perform 4 functions. One is GPIO, which I already told. Each pin each of this pin, that is 32 plus 16, each pin can act as general purpose input output pin, or they can act as transmitter or receiver, pulse width modulation, and external input. So these are the 4 different function what each pin can be configured to perform. But in majority all of our experiments will be using each of this 48 pin in the general purpose input output mode itself. We are not going to use it as transmitter or receiver, pulse width modulation, and external input. Majority in all the experiment will be using all the 48 pins either as input port or as output port. Now for example, here I have an example. Say I am taking this P0.0, that is the 0th pin of port 0. Now these are the functions. If I want to make this 0th pin of port 0 to operate in general purpose input output mode, so then this is the value I have to give 0 0. If I give 0 0, then I have this P0.0 acting as general purpose input. Now where to give this 0 0 I'll explain in the next slides. Next, similarly, if I want to make this 0.0 0th pin of port 0 to operate as transmitter, then I have to give it as 0 1. And similarly for 0.0 to operate as pulse width modulation, I have to give it as 1 0. And for port 0.0 there is no fourth function, it is not defined. Now similarly, if I take the first bit of port 0, P0.1, so this again 0.1 also can function as general purpose input output mode, and to make this also to function as general purpose input output mode, so I have to give the bits 0 0. If I give the 0 0 value, then this acts as general purpose IO. Similarly, so now this 0.1 cannot access transmitter, it can access receiver, whereas 0.0 can access transmitter when you give the bits 0 1. Now this 0.1 acts as the receiver, and when I make 1 0, so P0.1 acts as PMW, and similarly if I make 1 1 as the bits, so this particular pin acts as the external interrupt. Now to define the functions for 48 pins we need, so that means I told each now to define the functions for 48 pins we need these many bits, 96 bits. This is what I am taking. To define the function of one pin I need 2 bits, because each pin can perform 4 different functions. To represent 4 different functions I require 2 bits. Now like this I have 48 pins, 48 pins which can act as general purpose input output. 48 into 2 I require 96 bits totally. 96 bits in order to represent all the 4 functions of all the 48 pins. Now in order to do this, in order to achieve this, now LPC2148 has something called as PINSEL register, meaning pin select registers. Now LPC2148 has 3 PINSEL register. One is PINSEL 0, PINSEL 1, PINSEL 2. Pin select register 0, pin select register 1, PINSEL register 2. Now each PINSEL register is of capacity 32 bits, hence 32 into 3. I have 3 such registers, and the capacity of each register is 32 bit. Now in the previous slide I explained I require 96 bits in total to represent the function of all the 48 bits, 48 pins. Now I have 3 registers and the capacity of each register is 32 bit. 32 into 3, capacity of each register is 32 into 3. I have 3 such register is equal to 96 bits. Now these 3 pin select register are going to satisfy my requirement. Now what is PINSEL 0? Now PINSEL 0 is used to define the function for port 0 pins. That means using PINSEL 0 register, I can define what function the pins of the port 0 should perform. Now port 0 pins, that is again from P0.0 to P0.15. Using this register I can tell now what each of this pin from 0.0 to 0.15 which function it has to perform. Now I have written port 0 here, port 0. Again see, to define the function of one port pin, how many bits I require? 2 bits. And what is the capacity of one PINSEL register? 32 bit. That means using this register, one PINSEL register, I can define the functionality of 16 pins, that is P0.0 to 0.15. And why it is called PINSEL 0? Because this register you can use in order to define the function of the port 0.0 to 0.15. That is the reason it is 0. PINSEL 0 is used to define the function of the pins from P0.0 to 0.15. You can observe here. So these are the port pins of the port 0 from P0.0 to 0.15, and these are the bits available in the PINSEL 0 register. PINSEL 0 register. Now the first 2 bits of PINSEL 0, that is 0th bit and the first bit, are reserved for defining the function of P0.0 pin, port pin P0.0. And similarly the next 2 bits of PINSEL 0, that is 2 and 3, are reserved for defining the function of P0.1, port pin 0.1. Similarly 5, 4 is reserved for defining the function of port pin P0.2. Similarly 31, 32 is reserved for defining the function of port pin 0.15. Now this is all. Now if I want to make make all of this port pins from 0.0 to 0.15 to operate in general purpose IO mode, now I have to make this as 0, 0. The 0th bit of PINSEL 0 and the first bit of PINSEL 0, I have to make it as 0, 0. And if I want to make all these port pins from 0.0 to 0.15 to operate in general purpose IO mode, I have to make all these bits 0, 0. Now similarly, now this is for making the port pin 0.0 to 0.15. I am using PINSEL 0. And similarly, what if I want to define the functions for the port pin 0.16 to 0.31? Then I'll make use of PINSEL 1. PINSEL 1 is again for making the port pins of port 0 from 0.16 to 0.31, selecting the functions for those pins. Here PINSEL 1, again it's again a different register which is using which is 32-bit register. Now I have P0.16 to P0.31. Among the 32 pins of port 0, now I have told you how to define the function for each of these port pins from 0.0 to 0.15, that is by using PINSEL 0. And similarly for defining the function for the port pin 0.16 to 0.31, I'll make use of the PINSEL 1 register. So again it has 32 bits. If I make all this, these are the 2 bits of PINSEL 1 which are reserved for defining the function of P0.16, and similarly 32 from PINSEL 1 is reserved for defining the function of P0.17, and similarly 31, 30 bits are reserved for defining the function of P0.31. And similarly for port 1, I told you can use only the P1.16 to P1.31 from port 1. P1.0 to P1.15 are not usable. Now there is only one register for it, PINSEL 2. Now you understood. PINSEL 0 is for making the port pins of port 0, lower port pins of port 0, defining the lower pins of port 0, defining the function of lower pins of port 0, and PINSEL 1 is used for defining the function of higher port pins from port 0. And similarly PINSEL 2 is used for defining the functions of the port pins from port 1, that is 1.16 to 1.31. I have the example here. Now to make the port pin 0.0 to function as GPIO, so this one, I want to make this particular port pin as function as general purpose IO mode. And what is that I have to do? Assign 0th and first bit of PINSEL 0 to 00 respectively. I have to make the 0th bit and the first bit of PINSEL 0 as 00 respectively. And similarly, to make the port pin 0.0 to function as transmitter, in the previous slide I told P0.0 can also be made to function as a transmitter. So that time you got to assign the 0th and the first bit of PINSEL 0 to 0, 1 respectively. That means 0th bit you have to make it as 0 and the first bit you have to make it as 1 respectively. That is what I showed you here. See here, to make 0.0 operate function as the transmitter, I have to make it as 0, 1. And similarly, to make port 1.0, this is not 1.0. Let me change, because 1.0 you cannot use 1.16. To make this bit 1.10 to function as GPIO, assign 0th and first bit of PINSEL 1 to 00. That is, this is again not PINSEL 1, PINSEL 2 it is. Make the 0th and first bit of PINSEL 2 to 00 respectively. And again, to make P0.28 to function as GPIO 28, where it is 0.28 here, to make this particular port pin to function as the general purpose input output pin, now I have to make 25th and 24th bit as 00 respectively. Now this is with this you understood how to use the PINSEL register in order to define the function of the port pin, whether to make it operate in the general purpose input output mode, transmitter, receiver, PMW, or the external interrupt. Okay, this is how you use the PINSEL register. Now PINSEL register 0 is for making the port pins, defining the function of the port pins from 0.0 to 0.16, and similarly PINSEL 1 is the register which is used for defining the function of the port pin 0.16 to 0.31, and similarly PINSEL 2 is the register which is used for defining the functions of the port pin P1.16 to P1.31. Now P1.0 to P1.15 they cannot be used. Okay, now we have the direction register. In the previous slide you understood now how to define the function of the port pin. Now the direction register, and these registers are used to set the direction of the ports. Now there are two direction, only two direction. One is the port pin can be an input pin or it can be an output pin. Now in the previous here, using the PINSEL register, you make the port pin operate in the general purpose input output mode by defining the bits to 0 0. 0 0 will make the corresponding port pin to operate in the general purpose input or output mode. So now how do I make the particular port pin either as input or as output? Now for that purpose we have two registers here. Register IO0 DIR, input output. This 0, this is 0, the middle one is 0, this is not O. This is IO input output 0 DIR. DIR stands for direction register. Now why it is the 0? Because this is the register which corresponds to the port 0, and similarly this is register which using this register I can define the direction for the port pins of port 1, and using this register I can define the directions for the port pins which are there in port 0. Hence this is called as IO0 DIR, hence this is called as IO1 DIR. Now I have written here. Now IO0 DIR acts as the direction register for port 0, hence it is called as IO0 DIR, and it is of capacity 32 bit again. So PINSEL registers, you understood, the 3 PINSEL registers, they were of capacity 32 bits, but again the IO0 DIR and IO1 DIR, so this corresponds to the port 1 and this corresponds to the port 0. Again these two are of capacity 32 bits. IO1 DIR acts as the direction register for port 1, and again it is of capacity 32 bit. Now in the previous class also explained, when I was explaining 8255, now there were three ports in it, port A, port B and port C. In order to make port A act as input port, now you're giving 1 there, and to make the port operate as output port you're giving 0 there. But here in LPC2148 it is reverse. To make any of the particular port pin operate as input, you're going to make it as 0, and to make any of the port pin operate as output, you're going to make it as 1. So this is opposite to 8255. 8255, 1 means input, 0 means output, but here it is 1 means input and 0 means so 1 means output and 0 means input. And another important thing is, so there in 8255 you are able to make either the entire port A, which is an 8-bit port, as input or as output. But here, so you can make each of the port pins of port 0 or port 1 either as input or output port. Say for example, if I make P0.0, this is one port pin of port 0, so this I can make it as input, and P0.1, if I want, I can make this as output. So that flexibility you have here. You can make each of the port pins of a particular port either as input port or as output port. Now you got to remember this, 1 is output and 0 indicates input. Now how do I make, for example, to make all the pins of port 0 to operate as output pins. Now in the previous example, using PINSEL 0, you have made the port operate in general purpose input output mode. Now in that again, how to make all the pins of the port 0 to operate as output pins. Now this is what I have to do. Now what is that I have to do? I have to make all the pins of port 0 to operate as output pins. Now which direction register I have to use? Since I'm saying port 0, I have to use IO0 DIR is equal to 0xFFF I have to give. Now that means all the pins, that is P0.0 to P0.31, I have to make them as output pins. Now I have to use FFF. What is FFF in binary? This is, that means, see, in this register IO0 DIR, what is the 0th bit? 1. Now this 1 in the register IO0 DIR, it will make the port pin 0.0 act as output, and similarly this bit 1 in IO0 DIR, you will find all these bits because they are assigned to IO0 DIR. So this second bit 1 in the IO0 DIR makes the port pin 0.1 act as output, and similarly I have made all the bits of IO0 DIR as 111, hence we have all the pins of the port 0 from 0.0 to 0.31 acting as output pins. And now similarly, how to make all the pins of the port 0 to operate as input pins. This is what I have to do now. Now input pins, right? For input, what is the value? I told it is 0. Now IO0 DIR, since it is mentioned as port 0, I have to use IO0 DIR is equal to 000, and this 000 in binary is 32 zeros like this. That means this 0 indicates, this 0 in IO0 DIR indicates the port pin 0.0 operating as input. Now and all the pins of port 0 from 0.0 to 0.31, they are acting as input pins. Now I have one more example. I want to make only P0.0 to P0.3 of port 0 to operate as output pins. Now I want to make only these pins from 0.0 to 0.3 to act as output pins, and the rest all as the input pin. Now IO0 DIR, since it is port 0, IO0 DIR is equal to 0x 000f, and only the last one is f and the rest all is 0. Now when I write the binary form of it, you can observe here. Now these are the 4 ones because of this f, and the rest all are 0. That means now the port pins corresponding to these bits are acting as input, and only P0.0, P0.1, P0.2 and P0.3 are acting as input pins. And similarly I have one more example. I want to make only P0.1 of port 0 operate as the output pin. Then this is the value 0x0002, because when I write it in binary, this is 1, this is P0.0 and this is P0.1. Now we have only P0.1 acting as output pin, and the rest all are acting as input pin. Next I have the example how to make all the pins of port 1 to operate as output pin. In the previous example here we understood port 0, and now similarly here with respect to the port 1, since I'm saying make all the pins of the port 1 to operate as output pins, now I have to use the register IO1 DIR is equal to, and the value remains the same, this is how it is. And similarly how to make all the